Hello everybody, welcome to another part of this number system tutorial. Okay, in today's video we're going to talk about how we can convert from binary to hexadecimal and octal and vice versa. I already seen how to convert from base 2 to base 10 and from base 10 to base 2. And remember I told you we have two other number systems other than base 10 and base 2, which are base 8 and base 16. Now before we get into this, I would like to mention something about base 8 and base 16. Okay, one of the first things is that I'll also give you a reminder that I told you the highest number in every base should always be less than the base number or the rightest number. That is, if we're dealing with base 10, the highest number in base 10 should always be 9. Can never be 10. And if we're dealing with base 8, for example, the highest number should be 7. And secondly, we all know that these numbers, that is base 8, for example, will be represented from 0 right up to 7. And base 16 also from 0 right up to 15. Now, you might notice something, okay? Once we reach a certain number, let's just say, let me use our 9, 10, 11, and let's say 12. Right? This is how we think my number will be represented. Right? Now, let's just say we have a number like 9, 12, and 10. We're going to have this 9, 12, and 10. Now, once you are given this question, you'll be somehow confused to know whether it is really 9, 12, 10, or it is 9, 1, 2, 10, or 91, 21, 0. You'll be confused. Because if you want to look at it, you might take it, another person can take it to be a base 10. That is 1 digit, 1 digit, 1 digit. However, this is the base 16 number. So, there's kind of a convention for us to not be confused whether we are dealing with base 16 or base 10 numbers, whereby numbers from 10 right up to 15 are given a certain labeling that is from A right up to F. So we have something like A for 10, B for 11, C for 12, D for 13, E for 14, and finally F for 15. See, this is how we can prevent from this kind of problems. So in this particular situation, I want to have a 9, C, and A. You see, 9, C, A, base 16. So this prevents the confusion, and whenever you see number like BA2, know that it is 11, 10, and 2, especially if it's going to base 16. Now, I'd like to mention another thing concerning base 8 and base 16 before we can get solving, because this method of conversion from base 2 to base 16 and base 8 is totally different from base 2 to base between base 2 and base 10. Totally different. Even though from base 10 to 16 and 8 can be the same, which we're going to see in the next video. So before that, let me tell you something about some other things about base 8 and base 16. Now, we know that base 8, that is the base of 8, it is equals to 2 to the power of 3. And if you are confused how we get 2 to the power of 3, you just need to divide 8 by 2 repetitively until you get 1. And you count the number of times you divided it. Like here, if you divide 8 by 2 one time, you get a 4. Divide the next time, you get a 2. You divide another time, you get a 1. And you divide it 3 times. And since you divide by 2, which is the base, which is the power of 3. Now 16, which is the multiple of 8, is 2 to the power of 4. Now, this power, so this power tells us that we need to use 3 binary bits to represent base 8 and 4 binary bits to represent base 16. Now, how do this binary combination of 3 and 4 combination of binary bits come about? I'm going to teach you 2 methods which you're going to use to derive this. See? And from there, you can easily allocate which 3 bits represent a base 8 and which one represent a particular base 16 or base 8 number. So we're going to start with the first method, which I think is the most complicated and the most tricky, and then we'll go to each one. But you can choose between the two which one suits you best. So we'll begin with base 8. And now, this is similar to base 10. You know, when you're counting from base 10, that's from 1 to 100. Let's just say as you're going from 0 to 9, you write 9. The first, that is the least significant figure, as I write in the maximum number. You move to the next, to the nearest most significant figure, you get a 1. And the least significant figure now has a 0. You see? So it's the same thing here. We're going to have primarily 0, 0, 0. This is for 0. I have no label the other digits. So we have 0, 0, 1. Now this one is complete since we're doing on base 2. So next we have 0, 1, 0. Go to the next 0, 1, 1, 1, 0, 0. We have, let me just put it here. We're going to have 1, 0, 1, 1, 1, 0, 1, 1, 1. Now we see that if I want to move to the next, we end up having 4 bits. And since in base 8, we use 3 binary bits to represent base 8, we end here. This is 0, 1, 2, 3, 4, 5, 6, 7. So we end here. So this tells that when you see this, 2, this 1, 0 here, 0, 1, 0 is a 2. This 1, 1, 0 is 6 in base 8. Now, the second method which I'm going to teach you is very, very simple, but at the beginning it will appear to be tricky. Okay? Now, we have 8 also. We divide this 8 by 2 since we are working with base 2. It gives us a certain value of 4. Let me just try and take this out. Now, it gives us 4. This 4, since counting always begins from the lowest number, which is 0, we are going to fill the first 4 row or the first column with 0. So we're going to have, we're going to have 0, 0, 0, 0. Now, since it is, we're still 4, we haven't arrived 1, we'll divide again by 2. Here we'll divide again by 2, which gives us the 2. So we'll go to the second column, we'll fill the first 2 rows of the second column with 2, 0. Well, I think it will better finish with the first column. Okay? Now, after we fill the 0, we go to 1. So here, we're going to have 1, 1, 1, 1. Now, for the next column, we have, since we have 2 zeros, we move to 1. After the 1 completed, we fill in 2 ones, we go to zeros. After the zeros, we go to 1. And if we still have to face some other places, we continue with the interchanging from between zeros and 1s. So here we're going to have 0, 0, 1, 1, 0, 0, 1, 1. Again, this is remaining 2 here. 2 divided by 2 equals to 1. This is where we end with the division. So here we have 0, 1, 0, 1, 0, 1, 0, 1. So you see, it's all the same thing. Now, it's all left to you to choose which one suits you best. So this is 0, 1, 2, 3, 4, 5, 6, and 7. Now, for base 16, I will apply only one method, since you can apply, I've already spoke about the first method. You can apply any method, it's the same thing. Like when we ended the 7 here, you just need to continue with 1, 0, 0, 0. Okay? Now, let's derive the base 16. Now, please draw this and label this to be 0, 1, 2, 3, right up to 7. Just try and pause the video and write it down on a piece of paper, because we're going to move to base 16. And as you can see, my board is not having a lot of space, so I have to write this out. Now, base 16, we are going to fill the first 8 rows. Since here, 16 divided by 2 is going to give us 8. I want to fill the first 8 rows of the first column with zeros before we move to 1. So you have 2, 3, 4, 5, 6, 7, 8. Let me take it this other side. 1, 2, 3, 4, 5, 6, 7, 8. Now, 8 divided by 2 again gives us 4. We continue. Now, here with the second column, the first 4 rows, 0. I'll try to be fast for the next operations to save time. Okay, we end up arriving at this. This is 15, this is 14, 13, 12, 11, 10. You can see convert all this to base 10 and you see what it gives you. Okay, so just try and write it on piece of paper because we're going to use this to work out. And now, when you convert from base 2 to base 16, let's say you have binary numbers like this. Since base 2, so since base 8 represented by 3 binary bits, So we divide it into 3. Okay? And if we are moving from base 2 to base 16, it's divided into 4. Since we need 4 binary bits to represent base 16. So without further ado, let's try and take the example which we have on the board. And when we convert from base 16 and base 8 to base 2, we're going to use the result of this example to end up having this. Okay, let's begin with the first. The first says we have 1 0 0 1 1 0. Since we're going to base 8, we divide it like this. Here we have 1 0 0 1 1 0. You can check on your paper. I'm sure you must have written it down. This gives you a 4. Here we have a 6. So this is equals to 46 base 8. Now let's convert this same to base 16. Now in the case of base 16, since if we when you divide, give a lot of priorities. When you separate them, give a lot of priorities to the least significant figure. So in this case here, let me first of all write it down the way it is. 1 0 0 1 1 0. We begin here 0 1 2 3 4. So we take it here. No, add 0. Well, if you didn't know about this, you would have just started counting from here 1 2 3 4 and you add a 0 behind, which is very different and not the method, not the way you have to do it. So now that we're divided like this, here we have a 2 and here we have a 6. So this is equal to 26 and this 8. Let me write this number down somewhere and keep them because we're going to use the same values when converting from base 8 and 16 to base 2. So I have 46 base 8, 26 base 8. Now we take the last example. Okay, let me give you a little challenge. Try and pause the video and solve this last example here on the board. And then you come back to check my. And by the way, along the way, you can consider giving me, if you like the video, consider giving me some thumbs up and subscribing if you haven't subscribed. And liking the video will enable other people like you want to learn for them to receive similar material, which you're receiving right now. And I'm sure you pretty well want them to enjoy it too as well. Okay? Well, now, this is our second example here. So in this case, for base 2, we have 0 1 1 1 1 1 1 0. You take this, you have 8 bits. So since all this by 3, start here, we come here, I'll add a 0. So here we got a 1, here we got a 7, here we got a 6. So we have 176 base 8. Okay? And coming to the base 16, we just divide it by 4. This gives us a 7. And this here is a 14. So instead of writing 14, write base 16. Now let me write the numbers somewhere and keep them so we can use them as an example when comments from base 16 and base 8 to base 2. I gotta use the black ink. Okay, now, when converting these numbers back to base 8 and 16, it's the same procedure. It's almost the same application. So we have, let's just say 46 here, base 8 is going to be equal to. Now, take each respective bits in base 10, base 8. Ask yourself, this bits here in base 8, what does it represent in base 2? It is 1 0 0. If you check your rolling paper or if you can try and derive it again, you'll find out it is 1 0 0. So here we are going to have 1 0 0. Then come to the next 6 in base 2, we're going to have the 1 1 0 base 2. And you can see that it's exactly the same thing we had in the previous example. Here was supposed to be 16. Now let me take the other base 8 example. First, before coming to 16. 176 base 8 is equals to, so here 0, 0, 1 and 7, 1, 1, 1, 6, 1, 1, 0. You could check the example. You see that this, now let me tell you one thing. Some people might think that this is different from the example I had. Now, when you know this 0 here, that doesn't really matter that much because, now, let me show something. These zeros here, let's just say the powers from what I've said in the previous video. If you haven't watched my video, you can check out the first video. There's a number system, introduction to number system. This here, power of 0, 1, 2, 3, 4, 5, 6, 7, 8. Now you can see what the difference comes from. Now, here what we have is 0 times 2 to the power of 7 or 6 whatsoever. And everything whatsoever by 0 is 0. Now, imagine if we had something like this. 0, 1, 1, 1, 1, 1, 1, 0, 0. You realize that the power here will start from 0, 1, 2, 3, 4, 5, 6, 7. Here we have the power of 6, you know, being 7. And 2 to the power of 6 is 64. 2 to the power of 7 is 128. Now, see where the difference comes from. That is why I said when you are separating the binary bits, give more little priorities to the least significant bits. Start counting from there as moving to the most significant bit, and you wish 4 or 3 in case of base 16 or base 8 respectively with separate. So please do not get confused. Now for base 16 I'll be fast with that. So okay guys, that's all for this video. Well, the next video we're going to be talking about converting from base 10 to base 8 and 16 and vice versa. Well, if you enjoyed this video, please share with your friends for them to also learn like you are just learning from here. And if you are new to this channel, please consider subscribing so you can get more videos like this. And please give me a thumbs up for the YouTube algorithm. And you can follow me on Facebook, or we can be friends so we can keep in a conversation. Whenever you have problems, you can send me a private message, okay? Well, see you next time.